Alright guys, tonight we're going to look at your next section of Chapter 5, which is 5-6, and it's on radical expressions and rational exponents. Radical expressions are going to contain the square root sign, which is also called the radicand. It's going to have an index, which is this number, and it's going to have a number under the radicand sign. A rational exponent, obviously, is going to be, let's say, 3 to the 4/5 power. And we're going to look at how those work. Let's start by looking at example 1, which talk about real roots. When they say real roots, what they mean is, for example, fourth roots of 81, which means what to the 4th power would equal 81? Well, if you think about that, the answer is 3. 3 to the 4th power would be 81. Now, if we had a 3 to the 4th power, it would be 81. Also, if we had a negative 3 to the 4th power, it would still be a positive 81, because this is an even number. So it's going to go negative to negative, which gives you a positive, times another negative, which is going to give you a negative, times another negative, which puts you back as a positive number. So you can say that a positive number has 2 real fourth roots when you're dealing with a 4th power. Cube roots, however, work a little different. For example, the number 125, negative, if you want the, the cube root of whatever that is going to be, or what to the 3rd power would equal negative 125, it is negative 5. It only has one root, because if we did negative 5 times negative 5, you get a positive. When you multiply it by another negative 5 for that cube, or that 3rd time, you're back to a negative. You're not going to have time to get back to a positive. Therefore, the only root of, or the cube root of negative 125 is negative 5. Now, if we look at a 6th root of negative 729, that negative number has no 6th real roots, because if we're looking at an even number, such as a 6th power, we know this is going to be, even if we start off negative, that's going to be positive. Then times another negative, that's going to be negative. Times another negative, we're back to a positive. Times another negative, we're back to a negative, and then the last negative is going to give us back to a positive. So it has no 6th root. It has to be positive. Now we're going to go on to look at properties of nth roots. Nth meaning the number. So if we look at the nth root of a times b, which that actually means, to break it down or break it apart, is the nth root of a times the nth root of b. So if we had the cubed root of 81, like we did in that first example, what I'm actually saying is, of course, that breaks down into 9 times 9, 3 times 3 times 3, which the cubed root of 81 is 3. If we look at the quotient property of roots, we see that the nth root of a divided by b, that is going to equal the nth root of a divided by the nth root of b. They just break apart. Let's move into example 2, where we have some simplifying of radical expressions. So looking at a, we have the cube root of 27x to the 6th power. If we want to break that up, meaning we want to factor it into only perfect cubes, we can pull out 3 cubed times x cubed times x cubed. That pulls out perfect cubes. Now, the product property that we just looked at tells us if we have this, then we actually have the cube root of 3 cubed times the cube root of x cubed times the cube root of x cubed. Now, those x's are going to, or I'm sorry, those cubes are actually going to cancel each other out. So this cancels that out and leaves me with 3. These cancel out and leave me with x. These cancel out and leave me with x, taking all of that out from underneath the radicand. So my answer for this question is going to be 3x squared. Now let's look at one of those where we have a quotient or we're doing division. So with that in mind, we're looking at a cube again. X to the third power over 7. Now the quotient property tells me, since we have it like this is actually the cube root of x cubed divided by the cube root of 7. So I need to simplify the numerator by getting rid of the 3's. I can't simplify the denominator yet because 7 cubed isn't a thing. So the top is going to become x, the bottom is going to remain as a cube root of 7. I now need to rationalize the denominator, or get it to a point that I can get rid of the radicand bar. So I need 3 sets totally across the bottom to fulfill that cube that's there. So whatever I do to the bottom, you know, we have to do to the top. That's the way it works. Everything has to balance. So I'm going to have the cube root of 7 times the cube root of 7 times the cube root of 7, both across the top and across the bottom. Now I'm looking at the product property. Again, I had x on the top. I now have x times 3, 7 squared, because we know when we multiply these two, we end up with 3, 7 squared, or the cube root of 7 squared. And on the bottom, I have the cube root of 7 to the third power. Now I need to simplify this. I cannot eliminate this 2 because that's a cube, not a square on the outside. But what I can eliminate are these, which is what I was trying to do in the first place. So now 7 is by itself on the bottom. And I have to leave the top. I can simplify this part, but I can't really do a whole lot else with this problem. 7 squared is 49. There is no cube root of 49. So that is my final answer. Okay, now let's look at rational exponents. As I said in the beginning, that is an exponent where it's going to be expressed as m over n, which is a fraction. And n are integers, and it cannot be 0. So again, that's m over n. This number cannot be 0, and it has to be an integer. Or both numbers actually have to be an integer. So let's look at this example. 16 and 1/4 actually equals, and hopefully you'll remember this, we did a little bit of this last year. It is going to equal, this is going here. That's my index. This is going underneath. This tells me what power this is going to be to. So, if we take this big number right here, and we have 1/4. Again, this is the index. This is the power. This is my base number. So what that's going to look like is 4th, 16, 1, which we really don't need that 1 there, but I'm going to put it there just for example's sake. So if I wanted the 4th root of 16, I know that is 2, because 2 to the 4th power equals 16. Let's look at another one like this.